So our first security and integrity activity: describe the security problems that may threaten the data of a company when social engineering is employed by a bad actor. Now, a bad actor is somebody acting maliciously when using a computer system. Explain the impact this could have on the company itself. The first point that I would cover is that social engineering is where an unauthorized user gains access to a computer system through falsely convincing them to let them in. You could elaborate on that, of course, give some examples, but that's your first point. Explain what social engineering is. Your second point then needs to be about what that problem could be. Well, the first thing is data could be copied and shared. That might be data they don't want being shared. That could be user account details, passwords, financial data. It could also be corrupted or deleted, so it could be messed around with so the data is useless, or just completely deleted and be gone. The final major problem is that it could be encrypted and held for ransom. Ransomware attacks are so common nowadays that I hear other teachers just tutting about it and rolling their eyes when they have school shut for a day or two because of a ransomware attack. It is scary that it is such a big problem, but what happens is the hackers encrypt your data, and you can't get that back without paying an amount of Bitcoin to those hackers. Now, of course, what you could do is delete the system entirely and restore from a backup, but that's assuming you have a backup. So what impact could that have? Well, a company suffering this kind of data breach could be fined under the GDPR, first of all, for any significant data loss. However, most of these companies will definitely lose money as a result of it, be that because they can't make transactions or they can't trace things, or there's an issue to secure the systems. The worst case scenario is the company is unable to operate and has to close. And this has happened in the past to really big companies. So it's really important that we secure our network systems. The cryptography activity is a nice little program to write with a few nice cheats to get some of the functionality working into it. I've written this as a very, very simple Python program here, the sort of thing that you could knock up in about 10-15 minutes really. There are no subroutines, there's nothing too clever going on here. It's a very, very simple one-pass program. First job is to decide whether we're going to encrypt or decrypt, and I'm just doing that by asking the user to type in an E or a D because it's a command line program. I'm then checking to see if it's an E, and I'm using the .lower command, the .lower function, to ensure that it's a lowercase e that they type in for encrypt. I'm then asking for the name or the text that they want to encrypt. I'm making that lowercase because I'm not dealing with capitals in this one, and repeating it back to them. I'm asking for an offset, and I'm making that an integer, and I'm repeating that back to them, and then I'm going through each letter individually using a for loop. And what I'm doing is getting the number of the letter using the ORD or the ordinal command. And that gives me the ASCII value of each letter. Now I'm taking 96 away because the letter A, the lowercase a, starts as number 97. So if I want A to be 1 and B to be 2, I need to take away 96. That's the first of the nice cheats we've got. I'm then adding the offset to the letter. I'm moduloing it 26 so that if it's gone above 26, if it's gone, if we've got Z and we've added 2 to it, it loops back and becomes B. That's what the modulo does. It gives us the remainder. So that means it's within that 26 character range. I'm then adding 96 back to it because the next job I want to do is display that letter on the screen using the CHR command. That turns an integer value back into the character by using its ASCII value. And I'm just printing all that out nice and simple. Now in the else option, it's the reverse, and you'll see how similar this code is. This is why symmetric encryption is quite problematic, because if you can encrypt it, you can easily work backwards and decrypt it. You can see it's almost the identical problem. It's almost the identical program, but what we're doing is instead of adding the offset, it's just taking it away. So it is just a copy and paste of the previous code with one plus changed to a minus. That's how easy it is to work backwards in symmetric key cryptography. So you can see why it's such a problem. If you've got the encryption key, it is easy to walk it back and work out what the decryption key is. The biometrics activity then explain using an example how biometric data could be used to allow access to a secure location such as a school, and why there might be objections to the use of this biometric data in this context. Okay then, well, We could give an example. The most obvious thing for a school to me would be fingerprints. Fingerprints would be scanned and stored in a database when people join the school, be that students or staff. And then when they arrive at the door, they scan their fingerprint again. That scan is compared to each recorded fingerprint, and if a match is found, the person is allowed access to the door. Now, it's important you mention that we find the record of the fingerprint and that then we check to make sure they're allowed access to that area. Now, what this means is biometrics and the database allow us to use our fingerprint to gain access to rooms that only we are allowed to. So maybe staff are allowed in all the rooms in the school, and students are only allowed to enter the student entrance or into the rooms that they're meant to have a lesson in at that particular time. This is a good use of biometrics, and of course it's great in a school because although students and staff commonly forget to bring in ID cards, they very rarely forget to bring in their fingerprints. However, why might there be objections? Well, first of all, there's the inconvenience of it. It's going to be a massive effort to fingerprint the entire school on that first day. However, once done, that data is in the system and can be used again and again. Some people, though, think it's an invasion of privacy to store fingerprint records at the school. However, a lot of these people don't understand that what's being stored is an encoded piece of data. It's a numerical or hash version of what your fingerprint swirls look like. Nobody's storing a photograph of that fingerprint in any system anyway. Finally, some people might be unable to access this system because of disabilities or individual needs. You can imagine that if somebody due to an accident has lost a fingerprint and it happens to be the finger that we are scanning, then they're going to have a different method of access. But on top of that, it's also going to be really awkward if it's on the outside door and it's a very cold day and people are wearing gloves, because it would slow down that process of people coming in quite enormously. The malicious software activity. Explain how a black hat hacker could be combated by the use of a white hat hacker in a corporate environment. Well, first of all, we need to define these two things. A black hat hacker is somebody that's usually trying to access a computer system maliciously, so for their own personal gain, and without permission. White hat hackers use similar techniques, but they do so with the permission of the company, and the point is that we want them to find security flaws so we can patch and fix them. White hat hackers then could be used to find security problems which we could fix, making it much more difficult for black hat hackers because there are fewer security flaws in the system. And what that does is that fends off 99.9% of all hackers.